All right, we are going to work on some right triangle trigonometry involving the angle of elevation and depression. And so when you have a person that's standing, you can actually measure using devices. You can measure the angle to an object. And we call this the line of sight. So if you wanted to know how tall this air balloon was in the air, you could measure this angle. And in this case, it's 38 degrees. And so when you're looking up, we call that angle of elevation. Now, if the person is in the balloon looking down, we call that angle of depression. And so when you have horizontal lines, you can make a vertical line there, then you have right triangles. And when you have right triangles, you can use the sine, cosine, tangent ratios to find how far off the ground is this balloon. Now, maybe you want to find out how far off someone is off the ground from eye level. But if you wanted to see like how far off the ground is the top of the balloon, then you would change your sight to look at the top. And of course, 38 degrees would be more. So everything I just said is summarized here. You can copy that down. Angle of elevation is an angle between a horizontal line and a line of sight, where the angle is above the horizontal line. Angle of depression is an angle underneath the horizontal line, where the angle is below the horizontal line. A couple things to notice, these two horizontal lines, those are parallel, and the angle of elevation and angle of depression are going to be the same if you're looking at the same spot. So if this person in the balloon is looking at their head and their head's looking at them, then the angles will be the same. And the reason why those are the same is because we have alternate interior angles. Now, if I drew a vertical line right here, which I'll go ahead and do, straight to the ground, that's going to produce 90 degrees. So since this is 90 degrees, we can use our trig ratios. So let's go look at an example here. Describe each angle as it relates to the situation shown. So you're at the top of the mountain looking down. That would be an angle of depression. Angle 2, you're looking up. That would be angle of elevation. Example 3, angle 3, you're looking down from the horizontal line, so that's angle of depression. And angle 4, you're looking up, so that's angle of elevation. All right, now let's go do some examples. From a point on the ground, I would say this is the point right here. So there's the point. From a point on the ground, 500 feet from the base of the building, okay? So they're saying from this point to the base of the building, that's 500. It is observed that the angle of elevation to the top of the building is 24 degrees. So let's see, here is the top of the building. So they are saying that this small angle right here is 24 degrees. And now if I'm going to the top of the flag, that would be 27 degrees, which makes sense that the bigger angle would be slightly more. So the whole thing is 27 degrees. Okay, find the height of the flagpole. So how tall is this flagpole? And so what we're going to do, and I don't want to confuse you, so I'm going to actually erase this 27 degrees. And what we're going to do is we're going to start with the first triangle. And the first triangle is right here. So what we're going to do is we're going to use SOHCAHTOA, and we're going to find how tall is this building. And the way we do that, we're trying to find how tall the building is. And this does make a right angle. Most buildings are vertical to the ground. And what we know is that right here, this is adjacent, and this would be opposite. So the one that uses adjacent and opposite is the tan function. So I would say the tan of my angle, I'm going to actually use a text box, that'd be a little easier. So tan of my angle, 24, is equal to, let's see, opposite we don't know, x is going to be divided by my a, which is 500. Remember, we then just put this over 1. We cross multiply. So that's going to be 1x, or just x. And then I'm also going to cross multiply here, which is 500 times tan of 24. And what I'm going to do is I'm going to type that in the calendar. And when I type that in the calendar, I get 222.6 feet if I round it to the nearest tenth. So 222.6 feet. Now remember, that's just the height of the building. They didn't ask for the height of the building, but we do know the height of the building is 222.6 feet. And some people might round that to 223. I would think for this example, it might be fine unless you need an exact answer. But now what we're going to do is we're going to look at a different triangle. And this triangle, we're going to look at the top of the flag, and it's going to go straight down. And this is going to stay 500. The only thing that's going to be different is that this angle, the whole angle, is now 27 degrees. So this whole angle right here, the bigger angle, is 27 degrees. And what that's going to do is that's going to tell me the height from the bottom of the building to the top of the flag. And I already know the height from the bottom of the building to the top of the building. So then to find this piece, I would just subtract those two numbers. So I still have O and A, but O is now the whole thing. A is still 500. And when I type this in, it's going to be tan of 27 this time equals, and I suppose we could use a different variable for this if you wanted. You can make that be y, but you're still going to divide that by 500. Remember, cross multiply. I put that over 1. I then cross multiply. So I take 1 times y. Remember, y is the distance of the whole thing. That's going to be y. And I'm going to set that equal to 500 times tan of 27. So I get y, 1y, equals 500 times the tan of 27. And I type that in the calculator, and of course you would expect it to be more than 222. I type that in real quick. I get 254.8. feet. So now, what's the height of the flagpole? The flagpole is not that tall, and obviously this picture is not drawn to scale, but if from here to here is 222, and from here to here to the total is 254, I would just subtract those two numbers. And so I'd go 254.8 minus 222.6, and I get, I guess it's not that bad. The flag is 32 foot tall. So I'd say the flag is 32.2 feet tall. All right. Now let's go look at these. Here they want you to find the angle of elevation of the sun. And so you have a boy who is 5 foot tall who casts a shadow that's 5 foot long. And I'm not very good at drawing. So let's say you had a boy. And the boy, there's the boy. And his shadow we'll call this the shadow, is 5 foot long. So we have 5, boy's 5 foot tall, his shadow is 5 foot long, and they want to know the angle of elevation of the sun. All that is this angle right here. So that's all they're wanting to know. Now here, this is a right angle because most people stand straight up and down. The ground, we're going to assume is flat. If it's not flat, that does change this problem. And you should know that this is a special right triangle, that this would be 45 degrees. So this would be 5 square root of 2. But in case you didn't know that, you would again say, okay, this is my opposite. This is my adjacent. And I would again use the tan function. It's not always tan. And remember, now it's the inverse button. So it's tan inverse. Whenever you're trying to find an angle, it's the inverse of O divided by A, 5 over 5. You type that in a calculator, and you get, oh, I didn't even need a calculator. I forgot that that's going to be 45 degrees. They didn't, I thought they were asking for the length. They're asking for the angle of elevation to the sun. Since those are the same, that has to be 45, 45, 90. So this angle is 45 degrees, or you use SOHCAHTOA. All right, find the angle of elevation to the sun. When a vertical post, again, I'm not good at drawing, so but I'm going to draw vertical means up and down. Vertical post is 15 foot tall. Okay. And now the shadow is 20 feet long. Now this is 20. So, and you know, the shadow could go this way, of course, but I'm just making the shadow go that way. And we're supposed to find the angle of elevation to the sun. That would be this angle right here. This one's very similar. This is still my O. This is still a right angle because it's a vertical post. We're assuming the ground's flat. We got O, we got my A. And so I type in my calculator the tan inverse of O over A. That's 20. You could reduce that to 3/4 if you wanted to. But tan inverse, I can't speak today, tan inverse of 15 divided by 20. And I get about 36.9 if I round to the nearest tenth. So this is around 36.9 degrees. All right, that is probably enough to get you started. You will definitely see angle of elevation of the sun in your future. I find this stuff kind of cool because, you know, when you're standing on the ground, they do have devices. I think it's called a clinometer. I think that's what it's called. And you can use the device to measure, you know, you can look through it and hold on. I think I'm saying this correctly, a clinometer, and you see this guy's using one. And I know it's kind of hard to see. But you put this tool, and there's ones you can make at home. And you use this tool, and it tells you angles that you could use to then calculate the heights of things. And there's the definition I got from internet. But it's very useful because you don't have to actually measure a tree. Like if you're cutting down a tree, you can use this device to figure out how tall the tree is using shadows, and then you can make sure that, you know, it's not going to fall on a house or something. So I think that's enough to get you started. I hope you have a good day.